All right, welcome everyone. We're very excited to have you here, and we're really excited for the presentation by Emily Rhea and Lindsey Elton of EcoAchievers about the Red Door of Truth. You're here with the Passive House Accelerator, and we are a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, videos, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. And with our co-hosts, Sean St. Amour, Kevin Brennan, and Mark Willey, we have launched Construction Tech Tuesday to share the technique, and the technology of passive house construction tech. Each week, we'll welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're glad you're here.
So I'm Kevin Brennan. I want to welcome you guys to the latest episode of Construction Tech Tuesday. We have an exciting series here for you. We'll be talking about blower door testing in some PHIUS projects. And we did the pre-show last night and excited to see what Lindsey and Emily have to bring. Let's bring it, shoot it over to Mark.
No, I get to say hello first. No worries, all good, Kevin. Hello, everyone. I am Sean St. Amour. Happy to be here today. We've got a great event, and I'm going to skip and keep my intro short, and let's get the party started because there might be some interesting things that pop up in all of our backgrounds today. Never know. All right, carry on, Mark.
So we're on track here. It's 6:02, and because Kevin and Sean will brief, I'll only take 10 or 11 minutes to give the introduction. Once upon a time, there was a place called Chicago Center for Green Technology, and there was a program called the Chicago Green Homes Program. And yes, it was operated by volunteers. And one of those volunteers is on your video screen right now. Her name is Lindsey Elton, and she found green and she pushed it forward by studying ResNet and third-party verifying and a whole host of other things. And you'll get that from her presentation today, because she's one of the people that run EcoAchievers. And along the journey in Chicago, I met Emily on one of her first weeks with EcoAchievers. Emily and Lindsey worked together, and she brought a whole bunch of experience and passion to it. And over a few clips, she got certified in everything under the sun, and she has a lot of acronyms after her name. And so the two of them dive into buildings and allow for these certifications to happen. But you came here for them. And so without further ado, the Red Door of Truth, Emily and Lindsey.
Hi, everyone. I'm Emily from EcoAchievers. I'm going to go ahead and share our presentation and get started. So our presentation has essentially two names. It's the Red Door of Truth, but it's also insights from PHIUS third-party verifiers, Lindsey and myself, as we've mentioned, from EcoAchievers. The Red Door of Truth, as we've discussed, is blower door testing, which is a major part of the PHIUS certification. It sometimes involves multiple fans to depressurize and pressurize large buildings. Sometimes it involves small fans for smaller spaces. But the PHIUS certification itself is really so much more than just blower door testing.
On what we've been talking about. So the blower doors that we saw earlier were from a variety of different projects, and really, to be honest with you, and so down here we've got Graham with a 3 blower door. We've got a duct blaster on the top right. I was doing a mid-construction inspection on the top left, and then actually this one on the bottom was a multifamily commercial project that only needed 1 blower door to complete the passive house testing. So we can get up to, 5, 6, 7, 8, however many fans. So this really is, you know, the key for a passive house, and it's a lot of fun. And yeah, it is the red door of truth. So you know, you know, it will not lie. So just wanted to give some background behind that. And the commercial PHIUS certification, contrary to what a lot of people might think and what we found on some of our projects, is that it's more than just the red door of truth. It's more than just the blower door testing. There's actually a lot that goes into it. It carries in Energy Star, it carries in Indoor Air Plus. It does not carry in Zero Energy Ready, which is found in some of the other passive house certifications, but there's the PHIUS QA workbook. So there's so many different elements when you're getting the commercial certification, and it's really important that you engage your verifier as soon as you can so that you're abreast and you're aware of what is happening. There's no duct testing, but you are going to have to do the tab, the testing and balancing, the whole building, blower door, all of the checklists. And so it's just from design to mid-construction to final. It's a coordinated process. And so this is just a rundown of what you'll see. One of the big important things is to make sure that when you have your verifier on here, that we're looking at to make sure that the PHIUS requirements, and specifically the testing protocol, that we can actually do it. Some of the mechanical designs that we've seen as of late do not fall into the typical passive house guidelines. So we really need to work with PHIUS in order to understand how they want us to do it. The blower door test also can be a variable. So even though passive house has its target, in order for the projects to comply with their WIFI model, sometimes the CPHCs will lower the target. So telling your verifier what your target is also important. And then mid-construction will be there for inspections to make sure that everything's looking good, final testing, all of our testing. So as we're getting started in this conversation, we just wanted to make sure that everyone was kind of on the same page of what the certification requires.
Now we can get into the fun part of going through some of the projects that we've worked on. And I think before we jump into it, I just want to say that as as the third party verifier, we ultimately want you to succeed. And going through we're going to go through some of the issues that we've run into on projects, and it's really for your information of things to be aware of, complications that can happen, but also that brings up the importance again of involving the verifier as soon as possible so we can head off any complications as early as possible. So we did a school renovation addition that had some complications just from the design. There were aspects of historical aspects, and there's actually two existing buildings that were quite a bit older, and I don't know the year of the two buildings, but they were built at different times, an elementary school and a junior high, that butted up to each other, and then the addition connected those two buildings. So it was a square addition that connected those two buildings at the corner. So part of that became difficult because there was actually designed openings to connect that new addition to the existing buildings. You can see on the right-hand side, one of those openings that had to be closed off for blower door testing because we were only trying to verify the addition portion. So we actually had to close off the 5 intentional openings between that addition and the existing buildings. So custom bucks had to be made, and plastic sheathing had to be used, screwed into the wall, taped and everything. And it became very difficult because we're pressurizing and it's blowing the tape off. And so it was a complicated process to actually test the addition. And then when it came down to the wall assembly of the existing buildings, was actually staying as the I'm going to jump back and forth for a second to explain a little better. But we ultimately, what happened was we had to test I'm gonna have to show you to get into it. The wall assembly of the existing buildings became the demising wall for the addition and the existing building. So that wall actually stayed on both sides, and the complications of air sealing that wall while keeping the facade of the brick, the attractive brick facade, definitely came into play. And ultimately, the air sealing wasn't super great on that. So we ended up having to, in order to test just the addition itself, we ended up having to depressurize the two existing buildings at the same time as the addition to negate the leakage across that interior wall. So, which became a whole nother series of complications, because there's two large existing buildings with different mechanical systems, different setups, and because they were so large, and actually to negate the pressure, we had to do it all at the same time. So the coordination between those different buildings was really difficult, and it took a number of times of testing to really get where we needed to be.
So I just want to add to that, and from the verifier perspective too, these aren't really items that were taught during our training. So this was a real learning experience for us as verifiers, as well as the coordination with PHIUS and talking with them and seeing how exactly they want us to approach this, because we went in there to do our test and it didn't happen as typically planned. So as Emily's saying, like, there's all these really unique aspects, and how do you deal with a wall that's been there for decades and decades and decades that they're not touching, you know? And so making sure that we've got the correct amount of pressure throughout the entire building. The bucks that Emily was mentioning blew open during that, you know, during our testing. So we're, you know, looking around during the test, trying to make sure that we've got everything done correctly. And some of the setup has changed. We were there for one test doing the pressurization, and it was pouring outside and it shorted out a fan. So like, there's just so many different aspects that came into this particular project that couldn't, you know, you can't be totally prepared. And so you just have to be able to be flexible, to know that you've got to think on the job, you've got to use all of your resources, and it may come back, you know, you may need to come back once, twice, even more.
Yeah, this was a project that they did not engage us in the beginning. They weren't really aware that they needed a verifier or a rater until they were under construction. So a lot of these items that we would have, you know, raised questions about and maybe formulated a plan for earlier on, we did not have the opportunity to do that. So we're just kind of thrown into what was already happening and had to deal with it. This is an example of what the mechanical system was on one of the buildings. So we had to work with the site manager to actually figure out how to get these existing buildings into the conditions for testing. You know, you have to shut down all the mechanical systems in order to do the blower door test. So figuring out what was even going on with this system was part of the process of how do we get this building to where it needs to be? How do we even really test it to get the results that we need? So that's part of what we do. Lindsey, do you have something else to say?
Yeah, I think in closing for this particular project, one of the key aspects of success for this was also the coordination and collaboration with the project team and with the builder. It wouldn't have happened if they didn't give up, and Eco Achievers didn't give up. So as Emily was mentioning, you know, when we come into a project, we're not stopping until you pass. And so that it's also, though, a delicate balance with, you know, like talking with PHIUS and making sure we've got all of our requirements done and getting data and trying different testing scenarios, but you also have to realize you're working with a client. So you need to be respectful of what their needs are and how they need to wrap up the certification for funding and things like that. So there's all these balls into place or that are happening, and it's exciting, but you're also, you know, like going into unknown territories as you know, traveling on the train as the tracks are being built. So and it's good. You just have to have faith and commitment to make it happen.
So another example of a project that we've you know, ran into some learning lessons on. We've worked on a few rec centers, and at least one thing I tend to always run into are these commercial doors that are not passive house level tight. So, you know, you've built this whole envelope to be super tight and well insulated, and then the doors get put on and they're, you know, hollow and leaky. And we find that for blower door testing and thermal bridging, these can be, you know, huge weak points. And that's just another reason to involve verifiers earlier on, so we can just bring that up in the design review, you know, especially, you know, the builder, you're building it to what was designed, and it's not the fault of anyone. And I don't actually even know if there are really good commercial PHIUS level doors, because I haven't seen them. So I would love, if anybody has that out there, please please share it, because I'd love to see what's out there. We also wanted to talk about just material use in general. We find that the fluid applied air barriers are the best from what our experience has been. And one of the major issues we see are connections between different types of materials. So that's just a really important thing to keep track of. It's also important we keep our role as a level of oversight. So we do all these mid-construction site visits, and it's important for multiple different parties to have that level of oversight and everyone to be aware of where the air barrier is supposed to be, what the air barrier details are supposed to be, so we can all keep an eye on it and help each other, you know, from builder, architect, whoever is doing the site visit, us as well. We do the site visits and try to look at those details to make sure they're not missed, because if you miss an important air sealing detail, it can, you know, it can be a big issue.
And some of these doors are transition doors too. So these are interior entry doors. You have your exterior doors, and then you come into like a foyer area, and then you walk through these. So that was used as, you know, for our blower door testing as an exterior door. And to Emily's point, you know, it's not functioning correctly. In order for us to get our passive house level testing, it doesn't have firm weather stripping. It doesn't have all of the gasketing, and it's meant to be more of an interior space. So having your verifier there and talking with the CPHC and the project team to make sure that we've got all of this correct, you've got the volume correct too, because that takes a chunk away if you're expecting to go to the exterior envelope and you've got, you know, you've cut some of that off in order to hit what the modeling has been. So what's also interesting is the materials that they chose were precast, insulated precast forms for these, which for a commercial project and actually for the blower door testing did a good job, because within that structure it isn't like framed construction. You know, those are pretty solid walls, and so the intentional openings or some of the other leaky layers aren't there. It's really, you know, making sure that where the panels connect, making sure that that's all sealed. So that was a good design feature of this. However, when we also looked at the thermal bridging component, the panels, the insulation doesn't carry the entire way through. So you've got areas of the wall that are just thick pieces of concrete that, you know, the CPHC has accounted for, but we're seeing that on the picture on the left with the huge blue striped line, there's a huge cold spot, and that was intended. So just all these considerations for materials and knowing how they're going to perform for the final product.
So also an aspect is the tab verification. So there's a number of things that go into tab verification, and there, for commercial projects, it's not unusual to have testing and balancing done, but for passive house projects, the verifier actually has to verify those results. Often that's done by the verifier testing themselves, but one thing that we've found consistently, and I think anybody who does that work knows that different testing equipment pretty much always gives different testing results. And because PHIUS thresholds are so tight, we want to make sure that, in order to set you up for success, we want to try to use the testing and balancing contractors' results, and that in order to do that, we need to be there to verify those results and see at least 10% ourselves. But we also need to see, what equipment they're using. We need to check that it's within calibration and that it's rated to measure the flow rates that are being measured. So, smaller bath fans need to be measured with equipment that's rated for smaller flows than the larger registers. So that's one aspect that we've run into complications with, mostly communication, because we are, we have to be there on site when that final testing and balancing is being completed. A lot of times that's, subbed out. So, maybe we're just talking to the mechanical contractor. And so it's a chain of communication to actually get between us and the tab contractor, so that that might be missed. But it's an important thing that has to happen for certification. So that's just one thing that we've run into. And again, the importance of communication. Can't stress enough how important it is to communicate with your verifier, and we want to talk to you. We want to be involved. So that's one. Go ahead.
Yeah, no, I think one of the aspects of this experience too is that the tab contractors, in addition to potentially a lot of the other contractors on the project, aren't used to this level of scrutiny, and us politely breathing down their back to make sure that everything's done correctly. So that's a learning lesson for the industry that is happening with all these different certifications, that, those details that they're doing and the particular work that they're performing is really getting looked at. And we were talking about this yesterday during our practice run, that that really it's important to support these contractors, as always, because they're the ones that are building and making the project work. So without them, without their detail, without giving them the resources, these passive house projects aren't going to be built. So they can be designed, but can they be understood? Can all of these different materials that, high-tech materials that maybe are supposed to be in these, but does the person who is applying them know how to use it? Is it done in the right temperature? Have they been given the right equipment to use? So all these different things, it's a learning lesson or a learning opportunity for us as raters to have an educational moment and to support them, because they're really the ones that are doing it. So I think we always try to keep that in mind, and so it's never it's working with them, so, which is an important relationship.
And another aspect of verifying the tab work is that some of it we do have to test ourselves, and some of it, especially with the commercial projects, it's different. They're different designs than what we typically would see with more residential projects, which the PHIUS certification was built around. So something like this we're seeing is actually a duct sock. You can see the layout on the left-hand side. And I don't know if anybody knows what a duct sock is, but you can see it right here, where it's actually attached to this hard duct here, but it is a flexible duct with holes all the way around throughout it. that runs all the way across, around the multi-purpose room. So to verify the testing and balancing, we're supposed to measure the individual registers and make sure that they are delivering specific design flow rates. But when they're coming, if the air is coming out of a bunch of holes all the way across the room, that becomes really difficult to do. So this was an item that we actually had to have a call with PHIUS, with the manufacturer of the duct socks, with the project team, the mechanical contractor. We all had to get on a call and say, how is this designed to work? Where's the best place to measure this? What should we use to measure it to get it accurate? So that just is another factor of the importance of communication, and we're learning new systems and new ways to verify these systems as we go as well. So some of it is a learning process as the commercial version of PHIUS is developing and becoming more widely used, and there's new types of systems for us to get to know. So as a kind of overarching theme of the conversation, we are regularly in communication with multiple different parties, and that is the best way that we have found to have a successful certification for any PHIUS project, including commercial projects. And it's ideal to keep us involved from the beginning in order to develop these relationships, and we're here to help, and we want to see successful projects.
I think another aspect of this too is using PHIUS as a resource and not seeing them as this entity that you can't talk to or converse with, and they're just sending out the mandates that you have to adhere to. We are in constant communication with them, and whether they like it or not, and it's just really important for us though, because in order for us to understand and to carry through and to keep integrity on the project, we're coming across things that we haven't seen, that they haven't seen, and to keep, everyone to keep in step, that communication is key. And I just like to also kind of give hats off to them for being open and being flexible and understanding some of the conditions on site and how a one size fits all does not work with the certification, even though it's a good guideline. But that's as technologies continue to develop, as we're working with different structures and everything, it's just not everything is going to fall into place with their guidelines. So they've been great to work with.
That's all from your friendly PHIUS Rater verifiers. Thank you so much for having us on to talk about what we do, and I hope that provided some great insights for you guys.
The Red Door of Truth has spoken. Sean, you're up.
Excellent. Thanks, Emily and Lindsay. And there's not like a good Mad Max, something to bring you back to those great vintage films, right? I tell you, you get to those job sites and you're like, wow, this is from outer space. And someone says, no, it's from Mad Max. And everyone gets it. Everyone gets the complexity and the turmoil that it's going to cause when you're having to deal with something from that vintage. No, great stuff. And I think Emily and Lindsay, just bring up the point, about how getting into these high performance buildings is all about teamwork, and that there's a variety of team members that you bring into your projects at different phases, and that the certifiers have a lot of experience and have seen a lot of buildings and a lot of projects and things going right or wrong. And I mean, this is kind of why we do these events, is so we can try to talk about more of these successes and failures. And again, it's great to have you guys on talking about a couple of instances in your projects. You're like, wow, that was a challenging build, and if you got something like it, here you go. So great stuff. I'm going to put the questions in the chat, and Kevin, do you have any points to bring up?
All right, great presentation, and I think you guys are the eco overachievers on taking on those projects. A renovation attached to a 50-year-old building with a Mad Max HVAC system that you don't know what it is, and then that's a big task. And then testing just auditoriums or large buildings like that is a big task, with maybe the need for a lot of fans. And I applaud you guys, because that's that's not easy. It's not an easy process to do, and just the testing alone, the setup and going across is not easy. So you guys are fighting the forefront of the testing process and teaching the trades out on the forefront. One question I saw that is always like a dear to my heart is, did you do any training on site with any of those general contractors before you got under construction or during construction, Emily or Lindsey?
So some of these, the school project, as Emily mentioned, we were brought on. They were one of the teams that only thought there was the blower door testing. So we came in a little bit later to that project. The other ones, we didn't do formal testing or formal training, no. During every inspection, we give insights or tell them what we're looking for. And we also do, during mid-construction, we do a practice blower door. So for all of our projects, we'll do a mid-construction blower door. And prior to that point, we're telling them during each on-site inspection where the leakage issues are going to happen, what we're finding, where they need to pay attention to. And then we have a prep call for that mid-construction test in which we give them a document that shows them where the fan's going to be, what needs to be in place for that. And then we want to make sure that we've got, I think that's the biggest training thing, actually, training tool is, and where the most aha moments happen is when you have a bunch of contractors that have never had a blower door test or been a part of a blower door test, and you turn on that fan and then you see the air that's coming in and you realize how your work impacts the success of the project. With these larger commercial projects, because there's such large structures, sometimes that doesn't happen as frequently, but when you're walking around and you're going through everything, it's more telling. So I think that's the biggest training. We offer training, but oftentimes we're not taken up on that, or they've got their own in-house, building science teams or wall assembly teams. I hear, Kevin, you might be an air sealing specialist and have a designation of your own. But it's those types of things that are really important for the success of it. And then for the testing aspect, we just try to involve, everyone as much as we can. So.
Kevin actually has a shirt that was given to him from our friend in California that designates him as an air sealing specialist, Lindsey. So he might put that on for us in the after hours. But you said that some of the contractors were not aware of some of the testings that are done.
No.
Would you like to bullet point a couple that are crucial and why it's important that you're brought in early? Emily or Lindsey?
Sorry, a couple of the contractors that are important.
A couple of the tests that so this contractor had the perception that y'all were brought in for the blower door, when in fact there's much more that you're brought in for, and typically you're brought in at the early stage. So could you tell us what that conversation is like to tell people about what's actually more inclusive and why you're needed on the front end? Emily or Lindsey?
Well, in terms of the air barrier and the blower door test, I would say pick a trade, any trade, and because they're all involved in it, electricians, plumbers, HVAC, everyone pretty much is creating some sort of penetration into the exterior envelope. So what they do to that penetration and making sure that it's taken care of is their role in the success of the blower door. So I would say that piece is key. I think for when we're looking at other aspects like the tab testing that happens and some of the mechanical testing that takes place, oftentimes we get slight pushback from the industry, I will say, just because I think one of the biggest things is that perhaps they haven't, had the oversight like we have to be. So we're paying attention to these details and we're asking them about particular aspects. And we have to hit a threshold, or the project has to hit a threshold. So, sometimes those conversations are a little bit uncomfortable because you don't want to get drilled about your particular trade. But overall, the information that they give, and I think the experience that we have is we try to be more supportive and not laying blame on anyone and just showing them how we can succeed.
That's the brilliant part that you guys bring to the experience, is you've done so many projects. And so you're actually committed to the success of all of the contractors, and that the modeling and the process comes together. So it's a huge benefit to have you all in, and anyone that's a third party verifier on the front end. So we stress that, and you see Adam Romano nodding. Sean, you want to take it to the first set of questions?
Can I actually add something to that, Mark, real quick before we do that?
Amen.
Also important in the design phase, there's so many things that are not testing related that are part of the PHIUS certification. Materials that need to comply with Indoor Air Plus standards. So we do material reviews, making sure that you're planning on using the right MERV level in your mechanical systems. There's a whole level, a whole list of submittals that we ask to see in those early stages to make sure that you're on track to meet all of the PHIUS requirements, because there's quite a few of them. So just want to add that it's not all testing related.
I think it's also key to, just before, sorry, Sean, I'm stealing your thunder, but that we have the CPHC, that we're in clear communication with the CPHC, because everything that we find on site, they have to reflect that in the WFI model. So if there have been any changes, we need to make sure, and sometimes they're a part of the construction team, but if not, if it's PHIUS or if it's an outside consultant, we just need to make sure that they know, so there aren't any surprises at the end if things have changed.
No, great point. And you didn't steal my thunder, because I'm coming from Thunderdome today. So
Yes,
all good. First one is Cameron Duncan had an early question. I think it might have been answered, but Cam, come on back on.
First, Lindsey, Emily, great presentation. Thank you. Excellent work. I actually deal with recreation centers, so your example was right up my alley. And unlike, I think, a lot of people here, I'm an owner in a way, in that I work for a recreation agency. And I write the documentation that gets the design team in, tells them who they need to include on their team. And when you were talking about having involvement early, my question is when do I write you in?
Now. So I think I saw that. Is it, SDs, or where is it? I would definitely say around that time. I mean, we've been involved. We've been fortunate to be involved, prior to the release of schematics. And then we've also been involved after construction drawings have been released. So I think, yeah, schematics is a good point, just at least to get that conversation going. We can give you the requirements even before that point, so that you can see what all, your contractors and what the different team members need to be adhering to. The sooner the better. So
right now I'm doing conceptual, we call it feasibility master plans. So I debated on whether just to rely on the CPH D or C, and or whether to bring you guys in earlier.
I mean, I think this would be a perfect time to do it, to be honest with you. People get used to the fact that you're going to have a verifier that's on there. We're letting you know what's going to be expected. The CPHC is really focusing more so on the compliance, the passive house compliance from a load perspective and some of the modeling perspectives, and they might not have, unless they're really keen or super intimate with the details. But it's really good to have us on board too, because we're a key component of the certification, and we are the ones that are actually doing the certification with PHIUS. So we're the ones that are going through the whole QA process and supplying the documentation and all of that material.
What is your climate zone and city? So we all know, Cameron.
We're just outside of Washington, D.C., climate zone 4, right near College Park, Maryland.
So it sounds like Eco Achievers is a perfect balance to your projects, right, brother?
Yeah, I don't think we will never tell you it's too early. I don't think that's ever a response. It's never too early.
Well, I'll follow up with you.
Great.
And Cam, I mean, that's a really good question, because a lot of times as we're getting into these first builds, we kind of keep going down our regular road, no, pun intended. But we think we can build a building the same way we've done it for the last 15 years. But once you're getting to high performance, you need to look at, and then we stress this up, and Emily and Lindsey said this too, so what is your plan and what is your plan? And part of that plan is developing the plan with the right team and getting the people on board. And I've seen it where in early construction that the client will hire, the team, literally, pay them an hourly fee. And then once it's ready to go for tender, it goes out to tender to get 3 bids. And hopefully the people that were brought in at the beginning will win, the project. But it's ensuring that planning phase is really done effectively, because we can, eliminate a lot of the change orders by just proper planning. And if you don't bring in the team early enough, you're going to be asking these questions or figuring it out way down the road. And hopefully Mad Max doesn't come back in with a change order, because it's going to hurt big time. So thanks, Cam. Brian, you are next in the hopper. Brian's question was, in conducting blower door tests in the past, I've experienced that in larger homes, you can't get to minus 50 pascals the single fan. Is there a cubic foot threshold for a single fan blower door tests? I think Kevin and Lindsey might have commented on that, but just to clarify.
I don't know if there's a anything regarding cubic footage, if there's a cubic footage threshold.
So essentially,
I posted a calculator in the chat. I'm not sure if you saw it, but the RetroTech has a calculator you could use, and it helps to size how many fans you might need and the volume and the square footage. So
yeah, so that's what we do. We take the volume, and actually Passive House, their metric is envelope enclosure. So we need to know the full envelope enclosure, and then based on the threshold, the 2018 standard is 0.06 CFM, whatever the threshold is. And then we do that by the envelope and or the square footage of the envelope enclosure, and that gives us our mark. But yeah, it's pretty much every fan is somewhere around 5,300, 5,400 CFM. So we typically use energy conservatory equipment, but RetroTech equipment, I mean, there's whichever one you're familiar with or comfortable with, but that's the process.
And that's what we were talking about as well, where we have to be in contact with the CPHC about what metric they've used in the WUFI model, because that, while 0.06 is the PHIUS requirement, they might have put in 0.03 in order to meet the energy requirement. So that's something we really need to know what we're shooting for, for testing.
Or it could be a 2015 project that PHIUS 2015 project that had a 0.05. So that detail is key.
John is still recovering from Adam Romano's 780 slides, so he needed to protect himself tonight, Emily and Lindsey, by wearing his goalie helmet. So back to you, Sean.
Yeah, okay. Thanks, Brian. Kevin's left us, so Peter.
So just one comment to add to Emily and Lindsey's point is that when we're talking about 0.05 and 0.08 CFM per square foot of surface area, that is very, very, very tight. The air barrier material is tested and certified as an air barrier material at 0.02 for the assemblies. So we're looking for as close to perfection out of that assembly in the real world, installed by real contractors on site. So the margin of error is very, very small between the windows, the HVAC, all the connections, the penetrations that might happen. So we're really looking for like 99% perfect on the air barrier. And then the other assemblies that are designed and input, they have to function, they have to work, you know, and one of those kinks in the armor, like Emily pointed out, like the weather strips or the door sweeps on those commercial ADA compliant doors could blow your blower door number up. And it's not easy to fix that once it's installed. So one thing I really applaud you guys on is that interim blower door that you guys are doing of getting. And really what I see that as is it's that scared straight kind of like, you know, like this is what's going to happen if you fail your blower door test. And if you don't straighten up and get your air barrier right, you guys are going to be going to blower door to jail, you know? And what really happens is you get buy-in from the team because they've never experienced a blower door before. And by having that experience on other projects, I have on my projects have started doing more mock-ups in the early stages. And the mock-ups are great teaching tools. You put a blower door on them, you show them where they are. And as somebody who hates to see resources thrown away or not used, I've been trying to convince the GCs to create their on-site office or their construction trailer or their meeting space as the mock-up for the duration of the project that is testable and has a window or a door, and they have to walk past it. So every time that team or that they go into an office, they have to walk by the work and see what it looks like. If they get a new person, they point out that base detail of the air barrier needs to look like this. Not what you did upstairs, it needs to look like this, because this is airtight, that is leaky as all hell. And we're working on it. You know, we have a few people that may consider it, but it's really a teaching tool, and you have to show them where the leaks are because we're fighting invisible ghosts that people don't believe exist, especially in today's culture where nobody believes anything. And to show them where the leak happens with a smoke stick opens their eyes, and it makes them say, okay, I can do this. And it's not just data and from reports and testing labs. So that's my 2 cents.
Speaking of that, we actually just got a a party size fog machine so that we can smoke instead of, you know, just like smoke sticks, but we can smoke huge areas during our blower door testing to be able to really visually pinpoint what's happening with the leakage. So
that comes with free candy, right, Lindsay?
And a disco ball. Yep.
Yeah. So Kevin, what you said there must be a new T-shirt. And I saw Zach left us for a minute. He went to go start printing. Blow your blower door up by the technical wizard, Kevin, and free munchies from Eco Achievers. Beautiful.
I think that touches on a really important thing. You know, Kevin touched on a really important thing, that there's all these different trades that have to seal their own parts, their own penetrations, you know, the windows, the mechanical penetrations, the plumbing, what have you. It's often left up to the individual trades. And a great solution is to have a dedicated air sealing specialist, one person or one team of people who is going around and making sure that that all of those aspects are being, you know, touched up and looked and have the proper attention paid to them to make sure that they're performing correctly.
So one title I've heard some larger GCs use, I heard it at summer camp, I think it was Walsh Construction. They have one person assigned to the exterior envelope, and they call that assistant super or the superintendent the skin doctor, where they inspect all the penetrations and all that. I personally like the title, the XO of airtightness, but it has to be somebody from the general contractor's team, either a superintendent or assistant superintendent, because at the end of the day, the point of the general contractors, they're responsible for everything. So they need to get buy-in that they're responsible for the air barrier and hold their subcontractors accountable. Some people call it the air boss. I'm not a big fan of the term air boss. It's very, you know, like I like the title of ass as well. You know, I've been called an ass plenty of times in my life for well-deserved reasons, and also for being very good at air sealing as well.
For commercial buildings, Kevin, isn't the technical term big ass?
It could be huge ass.
Huge ass. I'm sorry. Sean, where are we at with our timeline?
Well, we are going to have to postpone a few questions into the overtime because it is time for Emily and Lindsey to talk about their mentor or mentors.
Oh, yep. So I started actually as Mark mentioned at the beginning of this, I started many moons ago at the Chicago Center for Green Technology, and Tim Hefner, who is on the right, ran our program and is actually the reason why I eventually came to Eco Achievers, and for Emily as well. And then Bob Chomko was teammates with Tim for a program called the Heat Weatherization Program. And we did weatherization projects for low-income housing throughout Chicago. And both of them would not be here without them.
Yeah, so, and for me, Tim, I met because I was interested in getting into this industry, and I found out that, that he was in the industry and knew the information I needed. So I made the connection with Tim, and he ultimately introduced me to Lindsey and Jason at the time. And he's the reason that I am in this industry and working with Eco Achievers. I also have another one that I didn't send a photo in because you already have the photo of Lindsey, who has taught me everything I know from when I started at Eco Achievers and supported me for all of my certifications and growth. So she's definitely one of my mentors.
So Lindsey, take a bow. It is well deserved. I mean, it's one thing to be involved in all this, but again, educating our youth and being connected and being a mentor is a great thing. So just fantastic. So thank you for sharing your mentors. Again, it's really important that we understand where you've come from, who you've learned, and hopefully we can either have them on or they'll have some other they've inspired other people to bring Brett on. So Zach, over to you.
All right. So I just want to say, as is my want at this moment in the show, that our work would be impossible were it not for our sponsors. So I want to quickly give a shout out to these fine organizations. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minotaur, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are BR+A, Brennan Insulation and Airtightness, Inotech Windows and Doors, and US Engineered Wood, T-Stud. Tomorrow we have, or right now actually, we have our podcast available, the latest episode published yesterday. And it's a great conversation with Brett Seriani from Seriani Designs in Australia. He has a background in both structural engineering and architectural design. So he is doing some really interesting work around structure, around operational carbon and thermal bridging, of course, around structure, but also embodied carbon. So it's a really, I think, a timely conversation with Brett Seriani and co-host Matthew Cutler-Welsh on the Passive House podcast. Tomorrow, Lois Arena from Stephen Winter Associates will join us to share some really critically important lessons learned around VRF systems, particularly when they're applied to affordable housing, multifamily projects, and ways to avoid the pitfalls of overheating and other issues. So if you're curious about those potential problems and how to solve them, Lois has the answers for you tomorrow. Next week, we'll be joined by our own Kevin Brennan, as well as Aaron McCormick from 475, and they will be speaking at Construction Tech Tuesday about fluid applied air barriers. Don't miss that. And then Wednesday of next week, we'll be joined by Deborah Moelis of Handel Architects, one of the top Passive House architecture practitioners in North America. She's going to be talking about the University of Toronto Scarborough project, specifically talking about how she guided the university toward Passive House during that project. So it should be very interesting. We hope you join us. Thank you.